Okay, so let's do a quick review on solving a system of linear equations. And we're going to use elimination. Okay, it's called elimination method. Okay, elimination method. So you guys did this in IXL, and the easy problems look something like 2x plus y equals to 5, and x minus y equals to 1. And it's almost like having two different people and trying to figure out what would match for both of them to be true. Like, are you guys both into scary movies? Are you guys both into ice cream? What could we find some common ground here that would be okay for both of you guys? And we could start guessing random numbers, but we worked with two methods already, one substitution and one called elimination. And the idea of elimination is we just add down. And in this problem, 2x and x don't cancel out, but look at the y's. And we have negative y and positive y. And those guys, if we add straight down, end up canceling out, and we end up with 3x equals to 6. So the whole idea of elimination is that we are eliminating one of the variables. So we start off with two variables, two unknowns, get rid of one of them, and we only have one unknown left. This takes us back to easy algebra, where we can just solve for x. X has to be 2. Okay? So now that we solve for one of the variables, and we say x has to be 2, what does y have to be? Well, if I plug in the x to the problem, and let's pick the second one because it looks like it's going to be easier. If x was 2 minus y is equal to 1, see, now this is a one variable problem now. We got rid of one variable, we're left with the other one. Instead of thinking about two things I don't know, I only need to think about the one thing I don't know. So we minus 2 to both sides. Negative y is equal to negative 1. Then we can divide both sides by negative 1 or multiply both sides by negative 1, whichever one you want to choose. Y is equal to 1. And we said we got to double check this to make sure this works. So if we say x is 2 and y is 1, well, let's plug it in. If x is 2 and y is 1, does that give us the 5 that we wanted? 4 plus 1 is 5. That's a win. This problem can get more difficult as we introduce numbers that don't match up. Like, I could have changed this one and I could have said 2x plus 2y equals to 5, and 2x minus 2, oops, made a mistake there, I copied it wrong. Erase this, that's just a y. 2x minus 2y equals to 2. I'm just changing it slightly so it looks a little different. So in this case, the y's don't cancel out, and the x's look like they might, but they're not different signs, they're the same sign. So if you make a dumb mistake, and you just say, hey, add them down, 2 plus 2 isn't 0, it's actually 4. So it doesn't cancel out. So what I want to do is, I want to change one of them. I'm going to change the bottom one. Why not? I'm going to make this all negative by multiplying by a negative sign, a negative 1. When I do this, we end up with the problem we said we're going to rewrite the new problem on the bottom here. Negative 2x plus 2y equals to negative 2. And we're going to use the first and third equation. You could, of course, always write it out, but I find that's just a waste of time oftentimes. If I don't change it, why should I rewrite it? So you could rewrite it if you want. But if you could keep everything in your head kind of in place on this paper, hey, the 2x and 2x get rid of each other. So we're left with a y and 2y is 3y is equal to 5 minus 2 is 3. Hey. Which is kind of what we got over here. So we would end up with the same answer. So we're able to change each of these equations by multiplying by some type of constant so that then they would match. And once they match, then they would cancel. They would eliminate. So we would go from 2 variables to only 1 variable. Now today's exercise, we are going to go from 3 equations with 3 unknowns to 2 variables and then to 1 variable. So here's the idea. We're doing a system of 3 variables. So if we have 3 variables, we need 3 equations. Okay, 3 variables means 3 equations. 1 variable, 1 equation. 3x equals to 12. That's 1 variable. I only need 1 variable to solve. If we have 2 variables, like what we just did back there, 2 variables, 2x plus y equals to 5, and 2x minus 2y equals to 2, right? 2 variables, 2 equations. So today, if we have 3 variables, 3 equations, 1 var, 1 equation, 2 vars, 2 equations, EQN equations. Now 3 variables, 3 equations. So we're going to start off pretty light. I'm going to practically feed you what one of those variables are going to be. So here is our first example, negative 3x minus 2y plus 3z equals to 15. Z is equal to negative 6 and negative 2x plus 3y plus z is equal to 3. Now, if you notice here, we end up with 1, 2, 3 variables in 3 equations. They're 3 separate different equations. Now, how do we simplify for this? Well, in this case, and you got lucky here, I gave you what one of those variables would be. So I said, well, hey, z for sure, z is absolutely going to be negative 6. So what you do is you plug in negative 6. Just plug in negative 6. And this 3 variable 3 equations actually turns out to simplify negative 3x minus 2y plus 3 times negative 6 is equal to 15. And negative 2x plus 3y plus negative 6 equals to 3. Now again, take a look here. We went from 3 variables, x, y, z. Now my next step right here, call this step number 1. I plugged in z equals to negative 6. We don't have z's anymore. When you plug them in, that simplify this. This will be negative 3x minus 2y minus 18 equals to 15. And that simplify this by getting rid of the 18 plus 18 to both sides. This is now negative 3x minus 2y equals to, that's going to be a big number. That's going to be 33. Over here, let's simplify the other one. Negative 2x plus 3y minus 6 equals to 3, plus 6 to both sides. Negative 2x plus 3y equals to 9. So we end up with 2 equations now left over with only 2 variables each. You guys ever play Clue, where you have to find out who did it, where they did it, and what they did it with? Right? Who did it, where they killed in the library, the kitchen, where they killed in the bedroom, and what weapon did they use? Was it the candlestick? Was it the pipe wrench? Was it the gun? So we're looking for these 3 unknowns. So now here's the thing. Now that we plugged in one of the variables, we're left with 2 variables and 2 equations. Turns out this is just a problem that we just did. Negative 3x minus 2y equals to 33. And negative 2x plus 3y equals to 9. Now, we're going to use our elimination method that we learned before. Do you think it's easier to get rid of the x's or the y's? There is no necessarily right choice. It's whichever one you think is going to be easiest. Okay, I want you guys to say if you guys want me to change. Next, you know what? We got to change them both. So we're going to change. I feel like the y is easier because one's a plus and a minus already. See, the signs are already different. If I change the x's signs are the same, so I would have to include a negative on it. So I feel like it's easier, less work slightly, to change the y's. Now, what number can I make 2y and 3y look like? I can multiply them by some number to make them both look like 6. So 6 works. So we're going to multiply the top by 3 and the bottom by 2. And when we do this, we end up with the new equation, negative 9x minus 6y equals to 99, and negative 4x plus 6y equals to 18. Now, I need to warn you one thing. When you're doing these problems, you want to make sure you copied your problem correctly. Double check every step in case you make a mistake along the way. Because when you make a mistake along the way, it ends up really bad. Like your one small negative sign kills the whole problem, and you wasted like 3 minutes. Looking at this step now, you'll notice that do the x's or y's now cancel out? Which one do they match? Right. So if we add down linear combination, negative 13x equals to, that's going to give us 117. We divide negative 13 to both sides. We end up x is negative 9. For those of you guys who don't know how to divide quickly, and there's actually a cheat. When I'm trying to divide, how many times does 13 go into 117? I don't know my division by 13, but I do know my multiplications by 3. 3 times a what would give you a 7 in the end? 3 times what will give you a 7? 3 times 5 is 15. 3 times 6 is 18. 3 times 7 is 21. See, it's a 1 at the end. 3 times 8 is 24. But 3 times 9, that would give me the 7. So maybe 9 would work. And in this case, yeah, it does. 9 times 13, well, it's just 9 times 13 is really 9 times 10. 9 times 3 is 27. And that's 117. Okay. So for this problem, we found out now x is negative 9. We were given way at the top that z is 6. Now we have to find one more variable. So we can use any of these equations here to find that last variable. Or I think it's going to be easier to use one of these. If you found one variable, in this case x, we can always use these easier equations to solve for the other variable y. So let's go ahead and use one of these easier equations. So negative 2x, which now x is, we know it's going to be negative 9, plus 3y is equal to 9. That's 18 plus 3y equals to 9 minus 18 to both sides. 3y is equal to negative 9 divided by 3. Y is equal to negative 3. So we solve for x, y, and z. Would this have worked if I chose the other equation? Sure. Negative 3, x is negative 9, minus 2y equals to 33. This is 27 minus 2y equals to 33. Okay, I'm going to get rid of the 27 now. Minus 27, minus 27. Negative 2y equals to, that gives me 6. Divided by negative 2. Y is equal to negative 3. Just like what we said before. And if you want to be super adventurous, you could have plugged this in on one of these original equations. Let me copy that. Negative 2, 3, 1, 3. Negative 2. Negative 2, 3, 1, 3. Negative 2, 3, 1, 3. You could have plugged in your x and your z, but that's just kind of redundant. But you could. Negative 2, negative 9, plus 3y, plus negative 6 equals to 3. And it will still give us the same answer. 18 plus 3y minus 6 equals to 3. That's 3y plus 12 equals to 3. 3y minus 12 minus 12 is equal to negative 9. Y is negative 3. There's all these different ways of doing it. But I highly not recommend you plug it into original unless if you want to check. Because why plug in two variables when you only need to plug in one here? You save a lot of time. So here is the basic idea. If you are given a variable, plug it in. Right? 3 variables, 3 equations. If you're given a variable, this is an easy problem. We're good, just plug it in. Now, I need to say one thing. I'm gonna give you guys the idea. Anyone ever been in a tournament, right? A tournament, like tournament brackets look kind of like a bunch of people playing, right? And then don't they fight off? Then they end up branching off. And then the winner of these end up fighting each other. This idea of a tournament. Okay. So that's kind of what we're doing. We start off with a bracket of x, y, and z. Okay? Brackets of x, y, and z. And you're going to fight. These guys are going to compete. And they're going to be left with, let's say, x and y. And when these guys compete, you're going to end up with one final bracket of just one variable, x. Okay? Now, if you say x is equal, let's say, a number 2. Well, now you know x is 2. And then we can solve for y. And let's say y becomes 3. So now you know x and y, and then you can find z. So first our goal is to go forward to solve for one variable, and then go backwards to solve for the rest. Now we're going to do one more problem with substitution. And this problem is, what if they substitute not just one number, but they give me a whole equation with other variables? So here is a fancy one. 2x minus 3y minus 3z equals to negative 30. And negative 6x minus 3y minus 6z equals to negative 33. Make sure you're copying this correctly, because a simple mistake of a negative sign would just give us bad dreams. Okay, and x equals to y minus 9. X equals to y minus 9. Some problems you may see, hey, they give you 2 variables, which is fine. So please take a look. X is y minus 9. So what we're going to do is we're going to say, hey, I start off with 3 variables. X, Y, Z, X, Y, Z, X, Y. Hey, that one doesn't have a Z. Maybe we can use it. And it's already set up for substitution. X is Y minus 9. So every time you see an X, you're going to write instead Y minus 9. 2X, which is instead Y minus 9. And I'll show you guys real quick, why do we do this? And then the second equation, negative 6X, which is now Y minus 9. Okay, all right. Now, let me make the big idea. In these equations here, they're both X, Y, and Z. 3 variables, 3 unknowns. Someone caught a mistake here. This is supposed to be a 3Z, all right? I just miscopied it. Thanks again. Okay, so we start with X, Y, Z, X, Y, Z, X, Y, Z. Now, 3 variables, 3 unknowns, that's a lot of stuff to not know. But if you look at our new version here, it's only Y and X's. Only Y's and X's. So we took the X idea out of the way, say, you know what, I'll deal with you later. But right now, you know what, we only have to look at Y and Z. So let's go ahead and simplify the problem. Multiply by 2, multiply by 2. You guys can actually save time if you want by just multiplying by 2 here. You could just multiply this by 2. So we're going to write 2y minus 18 minus 3y minus 3z equals to negative 30. Second part, negative 6y plus 54 minus 3y minus 6z equals to negative 33. Some of you guys might be saying, that's all I'm writing. You're right, because this is a harder problem. There's more work to show. A lot more things can go wrong. Let's look at like terms. I have like terms of 2y and negative 3y, negative 6y and 3y. I can combine those. And this 18 here needs to be moved to the other side. 54 needs to be moved to the other side. When we do that, we end up with negative 2 minus 3 is 1y minus 3z is equal to moving that 18 over. It's going to be 12, negative 12, because we added 18. We end up with negative 6 minus 3 is negative 9y minus 6z equals to moving that over. Negative 54 is a huge number. That's going to be negative 87. That doesn't look pretty. But one cool thing is, instead of having 3 variables, 3 equations, we only have 2 variables with 2 equations now. 2 variables and 2 equations. Our last step here, we're going to say, hey, do you guys want to get rid of the x's, sorry, y's or z's here? Y's or z's? And for me, I'm actually more comfortable getting rid of the z's because I just need to multiply by 2. If I wanted to match the y's, I would have to multiply by the number 9. So that's too big. And for us to cancel, I'm going to multiply it by a negative 2. Multiply both sides by negative 2, negative 2. Why did I choose negative 2? Because negative 2 times the negative, it becomes a positive 6, which cancels out with this negative 6. Remember, we're trying to make a match and then cancel that match. You could have multiplied by negative 9, and that would have been totally okay. You would just solve for a different variable, which is, again, whichever one you think is going to be easiest for your brain. So when I rewrite this, so I'm rewriting it as positive 2y plus 6z equals to 24. So we go from a 3-variable equation to 2-variable equation, which is what we've been practicing. Hey, look, they match up. These guys here now match up. So this becomes negative 7y equals to, this number is negative 64. 3. Okay, divide both sides by 7. Negative 7, I'm sorry. Y is equal to 9, positive 9. Hey, we solved for a variable. Now, we could go back and work backwards. Okay? Now that we solved for y, remember these equations here? If you solve for y, you can solve for x. If you solve for y, you can solve for the other variable x. So let's use that. Negative y, which is now 9, is equal, sorry, not equal, minus 3z equals to negative 12. Well, hey, look, I plugged in the y, now I can solve for x. Sorry, dang, I keep saying that, solve for z. So negative 9, I'm just gonna skip this step. Just add 9 to both sides. Negative 3z is equal to negative 3. Divided by negative 3. Z is equal to 1. So we solve for y and for z. Now we have to solve for x. Let's take a look back here. Look what's nice to set up for us. X right here. If you give me y, I can give you x. So let's use it. X equals to y minus 9. X equals to y minus 9. Well, y we solved for was 9. X equals to 9 minus 9. X is equal to 0. So if I did everything correctly, these three values, x, y, and z, will be the same solution for all three initial problems. Our starting values, let me go clean this up a little bit. So when we started the problem, we were given x, y, and z. And our claim now is that if x was 0, y was 9, and z was 1, x, y, and z, 0, comma, we said y was 9, and z was 1. This would be true for all three statements. So I'm going to check just the first one. Here we go. Let's check the first one. If x was 0 and y was 9 and z was 1, do we end up with negative 30? 0 minus 27 minus 3. Oh my gosh, it worked. Okay, let's do one more example. So y is equal to x minus 4. So they gave us a whole equation there, not just a number. And 5x plus 3y minus 6z equals to 24. And 6x minus y minus 2z equals to 37. So go ahead and plug in y. So I want you guys to rewrite the problem. 5x plus 3, and then plug in y minus 6z. Now, if you want to save time, you could just multiply it in. 5x plus 3x minus 12. You could do that. But just be careful, because oftentimes people make small mistakes, whether it's a negative sign or they don't distribute correctly. But go ahead and plug that in. 6x minus y. Oops, sorry. We don't write y, we just write parentheses. So why don't you guys spend let's spend 30 seconds, copy it in, and then go ahead and do the next step, multiply it out. So you end up with this line here. Once you do that, combine like terms. So I'll let you guys do this. So again, I made a mistake. I copied a 7. That's actually a 4. That's a 4 over here. Okay, so hopefully you guys were able to get to this point by yourself, where we have two variables and two equations now. We started with 3. We plugged in one of the variables using substitution, and now we're left with only 2 variables with 2 equations. Okay. So 37 was actually a 30, 36 was actually a 37. That becomes a 33. And then we said we're going to multiply both sides by a -3. Draw parentheses, please, around it. If not, it looks like you're minusing 3. We're -15 plus 6z, and that's going to be -99. Now again, you could rewrite it completely, and that would look nice. But if we're trying to save time, just keep it straight in your brain. Just writing it over again, but you don't have to. Okay, next step for you guys, please combine like terms. We'll eliminate what cancels out those like terms. And once you get the answer in the chat, go ahead and post what x will be. Go ahead and post the answer what x will be once you get there. Good job. Okay, great. All you guys got there. Now, once we solve for x, look back here. What could we solve for? If I solve for x, now we can solve for what? Okay. And if you don't want to use these equations, you can come back and use any of these. Maybe this one would have been easy right here. Use any of these equations that we wrote out. So I'm going to use, actually, this guy here. So 5x minus 2z equals to 33. You could use 8x minus 6z equals to 36. So please plug in the 9 so you can solve for z and tell me what that's going to be. Plug in the 9, solve for z. Cool. I'm seeing a lot of good answers. Good job. Right, now we have x, now we have z. Let's go take a look at my original equations. So we're still missing y, so we can solve for that now. Or if you want to be adventurous, you can plug into any of these other 2 equations. Since we have our x and our z now. Okay. So let's go ahead and solve for y. Y is equal to x minus 4. Let's use the easy one. Why not? Hey, x is 9. Okay, someone got it. Cool. So this is how we're at the answer. The answer is an x, y, and z. X is 9, y is 5, and z is 6.